Okay, so we're doing chapter 9, problem 79 here. And it says a huge balloon and its gondola have a mass big N and are in air stationary with respect to the ground. There's a passenger of mass little n, which climbs out and slides down a rope at a speed v, measured with respect to the balloon. What speed and direction relative to Earth does the balloon then move? Okay, so if we call the origin of the coordinates the center of mass of the balloon, and the gondola and person at rest, since the center of mass is at rest, the total momentum of the system relative to the ground is zero, which is important. So we need that. The total momentum is zero. And the man climbing the rope cannot change the total movement of the system since he's in the system. So if we call upwards positive y and downwards negative y, such that this is our coordinate system, we know that the velocity of the man is negative v because he's moving at a speed v. Okay. So that means the velocity of the man with respect to the ground is now given as the velocity of the balloon with respect to the ground minus v. So we know this relation now, and we also know that the total momentum must be zero. So 0 then must be equal to n times the velocity of the man with respect to the ground plus n times the velocity. Oops, sorry. This is big N times the velocity of the balloon with respect to the ground. So now let's plug this in, and we see that n times vbg minus v equals big N, plus big N vbg equals 0. So we can solve this. So the velocity of the balloon with respect to the ground is now given as v times little n over little n plus big N. Cool. And this is also going to be upwards because it's positive as we see.